Hey guys, it's Em. Today we're going to be learning about the physics of the human voice. I hope you enjoy! One of the key things that makes us human is our ability to communicate through speech. Without our ability to use our voices, our way of life would be dramatically different. Even though we use it every day, it is very rare that we actually stop and think about how it works. Just like being able to move our legs so we can walk, we just accept that it works and move on with our lives. The way the human voice works is actually very interesting and, like you probably would expect, differs depending on whether you are talking or singing. Every time you open your mouth to say something to a friend, ask a teacher a question, or sing along to music in the car on your way home from school, you are using your voice. I use my voice, of course, when I speak, though I consider my most enjoyable use of it to be when I sing, especially in a choir. Most people know that the voice is produced by vibration of the vocal cords, also known as vocal folds. Though the vocal cords are the most important part of the body in the production of the voice, what people don't realize is that they're only part of the story. The sound produced by the vibration of the vocal cords is actually comparable to the buzzing produced by the mouthpiece of a brass instrument, such as a trumpet. Anyone familiar with these instruments knows that by buzzing on just the mouthpiece, the rich sound that the audience is expecting can never be produced. The same is true with the human voice. If only the vocal cords were responsible for our production of sound, our voices would not be desirable things to listen to, nor would we be able to understand each other. The way the voice works starts when air is inhaled. Remember, science doesn't suck. There is no such thing as a sucking force, so you don't just suck air into your mouth. Instead, air moves into your lungs when a pressure vacuum is created by the diaphragm lowering and the rib cage expanding outward. After this, air exits the lungs through the trachea, otherwise known as the windpipe, and goes into the larynx, which you may have heard called the voice box. Within the voice box, there are two vocal cords. This is where the magic happens, thanks to the Bernoulli effect. Bernoulli's principle states that a rise in pressure of a fluid, which, as a reminder, is a gas or a liquid, is always accompanied by a decrease in velocity of that fluid. Conversely, an increase in velocity always occurs alongside a decrease in pressure. Basically, in this big long equation, anything that has a subscript of 1 is the pressure, velocity, or height of the fluid at the first position, and anything that has a subscript of 2 refers to the second position. This principle is most often cited when explaining lift for an airplane. When air encounters the wing of a plane, it has to split, so some of the air goes over the top of the wing and some goes under it. Because of the shape of the wing, the air going over the top has a longer distance to travel, so it moves faster, while the air beneath the wing moves slower. The increase in velocity on the top of the wing causes a decrease in pressure there, while the decrease in velocity on the bottom causes an increase in pressure. Because fluids always want to move to an area with less pressure, the air on the bottom pushes up on the wing, creating lift. Bernoulli's principle is also used to explain how vocal cords vibrate. First, we have to establish when the vocal cords are open versus when they are closed. During normal breathing, the glottis, or the space between the vocal cords, is open, and when we sing or talk, it is closed. It is also closed when we swallow, and when we cough, it is closed and then open. When we go to talk or sing, the glottis closes. It is the interaction of air with the vocal cords after this point that produces the vibration.
I represent my two vocal folds. If I blow between them, you might assume that they're going to blow apart, right? That would make sense. But here is what happens.
As you saw in the video, when she blew on the two pieces of paper representing two vocal cords, they came together. This mimics what actually does happen when we use our voices. When the air column from our lungs reaches the closed vocal cords, pressure builds up until they blow apart. The sudden allowance for air to pass through causes an increase in velocity. This in turn causes the pressure to drop and the two vocal cords to move in towards each other, as you saw with the two pieces of paper moving in after air passed between them. When the vocal cords come together, we say that they have approximated. This opening and closing cycle repeats itself as long as air continues to pass through, producing a vibration. In the next video, a scope has been used to view the vocal cords vibrating in action as a person sings. Though it looks like the vocal cords are vertical, they are actually horizontal across the throat. The scope is simply looking down into the throat, so the image looks like this, where, if you had X-ray vision and looked at someone's throat from the front, you would see something more like this. Okay, on to the video. Notice that while the singer is singing a low note like this, the vocal cords are short and don't look very tense. Now, when she moves on to a high note, the vocal cords are stretched longer and you can see that they are more tense. Remember, this vibration of the vocal cords is only controlling the pitch and a component of the volume of the sound, not how it's going to sound to the listener. After being produced, the buzzing is amplified and modified by the vocal tract resonators. The vocal tract is the path from the vocal cords to the mouth, and the resonators are the throat, mouth cavity, and nasal passages. The unique sound of a person's voice is due to the shape of their vocal tract and where they place their sound, though vocal placement plays more of a role in singing than talking. The lips and tongue are responsible for further modifying the sound to create words. Without all the parts of the body I referenced in this video working properly, we would not be able to talk or sing. Not only would this make communication much harder, this world would also be extremely boring without everyone having the ability to express their unique ideas with their own unique voices. Appreciate your voice every day. After all, you're the only one that can produce it. Thanks for watching. I hope you guys learned something new today.